Hi again. Today we are wrapping up our life cycle inventory stage before we move on to the impact assessment stage. Once we have all our data scaled to the functional unit, we create an inventory table. Here we have a hypothetical example of an inventory table for a product. The functional unit is 1,000 disposable polyethylene bread bags. The inventory table therefore shows the sum of the different material flows or environmental exchanges from all the unit processes considered in the product. This bread bag example is a cradle to gate example, and it does not include the end of life of the bread bags. We see that we need 8.1 kilograms of crude oil for our 1,000 bags. And we also see what is emitted to the environment throughout the life of the bags. The results of the impact assessment step might require us to come back to the inventory and check individual environmental exchanges and make sure they are correct. The inventory can also allow us to better understand the particular resources being consumed and the particular emissions created by the product. So for example, if we were interested in how much water was used in the life of a product, we could find this in the inventory. Here we have an example of the total water used by the life cycle of 3 disposable coffee cup alternatives. This is a comparative life cycle inventory since it compares 3 alternatives. The results show us the water used per functional unit. The functional unit is 10,000 units of 16 fluid ounce cups. 16 fluid ounces is the volume similar to this cup over here. We see the difference in water quantities required per alternative. The original results are in gallons. We can convert this to metric units, in this case liters. From here, we can divide the results by 10,000 to find out how much water is required per single unit. Remember that this is the amount of water required throughout the life of the cups. Do you think that more than 1 cup or more than 1.5 liters of water per disposable cup is a lot of water used? And that doesn't include the water used to make the coffee that you're drinking. The first question that comes to mind is how we can preserve the value of such products, at least in terms of the resources that went into them. Is a non-disposable cup the solution? What about all the additional water we would need to wash the non-disposable cup every time we use it? Remember that we account for this by scaling all the alternatives to a functional unit. This is a nice example of how LCA helps us to avoid simply shifting problems between products and instead consider the product holistically. What about using the disposable cup for a different purpose after we had our coffee, or at least putting the materials to good use? Now you're thinking like an LCA practitioner in the circular economy. Let's take another look at the results. We see that the expanded polystyrene foam cup requires the least water. With a quick scan of the results, we can see that we can save more than half a liter of water by choosing the expanded polystyrene foam cup. Does this mean it is the best alternative amongst the disposable cups? Well, this is only one resource out of the many required by this product. Emissions, such as CO2 and the amount of waste created by the use of such cups, should also be considered. If you're interested to see how the different disposable cup alternatives differ according to the various environmental exchanges considered, then you can download the report and have a look for yourself. That brings us to the end of the inventory analysis section. As a thought for the day, try to think about how either the incineration or recycling of our coffee cups could be included in a unit process. How should we include the energy we get back from the incineration, or the material we can get from recycling? Any ideas? If you don't have the answer, then don't worry, you soon will. See you next time.